All right, today we are working on topic 3 assessment, page 159 to 160. And we're starting out with number 1. So in your notebook, you want to make sure you clearly write your work out. So number 1, we have Dr. Peterson works 170 hours each month. What is the best estimate for the number of hours she works in a year? If we go to rounding, we've got a couple options here. The first one I jumped to is 180 times 10, which is actually on there. We want to look for the best option. So 200 times 20 would be a way overestimate, and 100 times 12 would be very much of an underestimate on the 100, and 100 times 10 would be an underestimate in both cases. So B is your best answer because we are looking for the best answer. Best. A banana contains 105 calories. Last week, Brendan and Lee ate a total of 14 bananas. How many calories does that represent? So we have 105 calories. Sorry, my touch screen is not touching very nice. And 14 bananas. We're going to use multiplication. Distributive property, 5 times 4 is 20, carry the 2. 4 times 0 is 0, plus 2. 4 times 1 is 4. And now we have to distribute that 1 of 14, which is actually a 10. So 1 times 5 is 5. 1 times 0 is 0. 1 times 1 is 1. And when we add it together, we get 1,470. So that was looking for an actual answer, not a rounded answer. Okay, moving down. At a warehouse, 172 delivery trucks were loaded with 48 packages on each truck. Part A, estimate the total number of packages on the truck. Write an equation to model your work. And part B, did you calculate an overestimate or an underestimate? Explain how you know. So we have 127 delivery trucks with 48 packages equals the total, whatever the total is. So if I want to estimate, I would probably go down to probably maybe make that 130 times maybe 50. I could do 100 times 50 would be another possibility. If you know what 13 times 5 is, you can do that. If you don't, like I know what that is, but you might not. And a quick way of 130 times 50, you can actually break this up using distributed property. You can say 100 times 50 would be 5,000, and 30 times 50 would be 1,500. And when you add that up, you get 6,500. That's one way you can use a distributive property. You could have also rounded that down to 100 times 50 equals 5,000. That would have been fine. And then you have to decide, did you calculate an overestimate or an underestimate, and explain how you know. So I am going to say that on this one, I did an overestimate because I rounded both numbers up. And if you chose the second choice, you probably have an underestimate because you dramatically, you rounded down one of the values there. So either one. Now, when you do the online test, if you get this wrong, remember, you always shoot me an email. And if you can defend your answer, I'll change it. Or if you want to change your answer because you messed something up, I will change that in my grade book. So remember to always send me an email with corrections. Choose all the expressions that are equal to 5,600. So for this, we have a little work to do. And remember our exponents. 10 to the second power is 100. 10 to the third power is 1,000. 10 to the fourth power is 10,000. So we have 56 times 100 is 5,600. So that works. 56 times 1,000 would be 56,000, so that would be a no-go. 56 times 10,000 would be 56 at 560,000, so that's not good. And 100 times 56 would be, that's good, 5,600. And 1,000 times 56 would be 56,000, so that wouldn't be good. So we only have two answers on that one. And if you had to multiply it out or write it out, 56 times 100, remember 56, solve a simpler problem, annex the two zeros. 56 times 1,000, 5 times 1 is 56, and annex the three zeros. 56 times 10,000 is 56, and annex the four zeros. 100 times 56, we already did that one up here. And 1,000 times 56, we already did that one over here too. So on these problems, you do have to do every single computation. You don't know if there's two answers or three answers, or one answer for that matter. The latest mystery novel costs $24. The table shows the sales of this novel by the bookstore. Part A, what is the dollar amount of sales of the mystery novel on Saturday? Write an equation to model your work. So the mystery novel costs $24. I have to move my screen up, so I'm going to put that there to remind myself. So on Saturday, when I go to the chart, there's 157 times 24, and I have to show my work. So I want to actually write out my problem. This is writing an equation, and I need to find out my answer there. That's how I'm going to show my work. So 157 times 24, 7 times 4 is 28. 4 times 5 is 20, plus 2 is 22. 4 times 1 is 4, plus 2 is 6. 2 times 7, which is actually a 20, so we put that 0 there. 2 times 7 is 14, carry the 1. 2 times 5 is 10, plus 1 is 11. And 2 times 1 is 2, plus 1 is 3. 8, 6, 7, 3. So our answer is 3,768, and don't forget your dollar sign. And that's writing the equation. What was the dollar amount of sales of the mystery novel on Friday? Write an equation to model your work. So on Friday, it's 103 times 24. So for 103 times 24, 103 times 24. I'm going to do 4 times 3 is 12. Carry the 1. 4 times 1 is 0, plus 1. 4 times 4. And a lot of times people, especially in the lower grade teachers, when you use these carries, a lot of teachers will tell you to cross them out so you don't get confused when you're using your next distribution. So 2 times 3 is actually 20. 2 times 3 is 6. 2 times 0 is 0. And 2 times 1 is 2. And then we add that together. 2, 7, 4, 2. So it's 2,472. And that's my equation to model my work. So moving on to the next page. While I erase here, you can move ahead and start reading the next problem. Lost my tools. Okay. All right, number 6, there are 45 cans of mixed nuts. If each can has 338 nuts, what is the total number of nuts? And in all the cans, write and solve an equation. So we have 45 times 338 equals the number of nuts. And the number of nuts equals, to figure that out in your notebook, 338 times 45. Remember, you can turn your notebook so you can use the columns in there to help you out. 8 times 5 is 40, carry the 4. 5 times 3 is 15, plus 4 is 19, carry the 1. 5 times 3 is 15, plus 1 is 16, so that's your first partial product. 40 times 8, 4 times 8 is 32. Remember I said you could cross those out if that makes it easier for you. 4 times 8 is 32, put the 2 down, carry the 3. 4 times 3 is 12, plus 3 is 15, carry the 1. 4 times 3 is 12, plus 1 is 13, add them up. And we get the total of 15,210 is our answer. I don't know why we want to know how many nuts are there, but whatever. It's an odd question. Oh boy, this is my new computer, and the touch screen is not as nice as my old computer. All right. There are 36 large fish tanks at the zoo. Each tank holds 205 gallons of water. How many gallons of water would it take to fill all the tanks? So they're not asking for an equation or anything here, but I'm going to write one anyway. I'm going to say 205 gallons of water times 36 equals whatever. So again, write out the equation in your notebook. Use the distributive property. 6 times 5 is 30. Carry the 3. 6 times 0 is 3. Or 6 times 0 is 0, plus 3 is 3. 6 times 2 is 12. That's your first partial product. Then 30 times 5. 3 times 5 is 15. Carry the 1. 3 times 0 is 0, plus 1. 3 times 2 is 6. And hopefully we can just blob the answer in there. 7,380 gallons. Number 8. And is that reasonable? We haven't really talked about that. So let's take a quick look to see if that's reasonable. 200, oops. I could estimate this. 200 times 40 is 8,000. And yeah, that looks pretty reasonable to me. Okay. Moving down. Kai ordered 1,012 baseball cards. Shannon ordered 5 times as many cards as Kai. Write and solve an equation to find B, the number of baseball cards Shannon ordered. So we have 100 or 1,012 and 5 times more, using B because they have a B right there. And what is my answer? So 1,012 times 5. 5 times 2 is 10. Carry the 1. 5 times 1 is 5, plus 1 is 6. 5 times 0 is 0. 5 times 1 is 5. So B equals 5,060. And we have a great illustration there of a way you can show the problem. I like that. Using a model. All right, number 9 and 10. Ted's sales goal for the month is 6,000. Ted sells 289 tickets for $16 each. He says, since 300 times 20 is 6,000, I made my sales goal. Do you agree with Ted? Let's take a look what he originally was supposed to, what he has. He sold 289 for 16 each. He decided to round that up and round that up. So if he has 6,000, do you think he met his sales goal? Well, you want to see, did he overestimate or underestimate? If he overestimated, he didn't meet his goal. If he underestimated, he would have met his goal. So what did he do? And in this case, he would say, no, he didn't meet his goal because he has an overestimate. His actual answer is going to be less than 6,000. He did not meet his goal. All right, for the next one, sorry. feel like I have to bang on this screen, this touch screen, to get it to work. Okay, number 10. We're going to have to solve each problem here. Draw lines to match each number on the left to its equivalent expression on the right. So I already have some values here. I'm going to need to solve the second column. So remember, 12 times 10 to the 0 is like 12 times 1. 10 to the 0 just is a 1. 12 times 100, solve a simpler problem. 12 times 1, and then annex your 2 zeros. 12 times 10 to the third is 1,000. So 12, and we're annexing 3 zeros. And really what you're doing here, let me just pop down here. 12 times 10. As a preview for the next chapter, when I say 12 times 10, what I'm really doing is I'm taking the invisible decimal that's sitting there after the 12, and I'm moving it over one place value, and I'm chucking a 0 in there to hold the place value. So what I'm really doing when I multiply by 10 is I'm moving the decimal over in that direction one place. When I multiply by 100, I'm moving it 2 places, and 1,000, I'm moving it 3 places. And that will help you out in our multiplication of decimals. You get a little preview of the next chapter. So really what we're doing in whole numbers is we are moving the decimal and putting a 0 in the space that's created when we move. So let's see when we match up. What do we have here? Let's see if we have all our values. They show up here. 1,200, there we go. 120, there's there. 12, and 12,000. And down the bottom here, for each question, choose yes or no to tell the number 10 to the second power will make each equation true. And remember, if you forgot any of your exponents, you can just make them into a multiplication problem to remind yourself what the answer is. So 10 to the second power is 100. So let's see if we plug 100 in all of these empty little boxes, will we get the value that they have written here? Is the answer correct? So 39 times 100. Solve a simpler problem. 39 times 1. We're multiplying by 100. We're moving the decimal 2 places. So that's why we're annexing those 2 zeros. So that's going to be definitely a no, because they have 390 there. 4 times 100. We're moving the decimal 2 places and annexing 2 zeros. 4 times 100 is 400. Yep, that's right. 20 times 100. Solving a simpler problem. 2 times 1. Or you could say 20 times 100. We're moving the decimal 2 places. So 2,000, and that's a no, because they only have 200 there. And 57 times 100. You're moving the decimal 2 places when you multiply by 100. So we're annexing 2 zeros, and that is what they have there. So that's a yes. So that's a no, yes, no, yes. How do you like how I snuck in that little preview for the next chapter? Multiplication of decimals. When we multiply by 10, 100, and 1,000, or divide for that matter, when we divide by 10, 100, 1,000, the decimal is going to go in the other direction. When we multiply by 1/10, the decimal is going to go to the left too, and we'll talk about that next week. So let's see what we've got for our last problem. Roseanne has 142 songs on her MP3 player. Teresa has 11 times as many. How many songs does she have? So 142 times 11 equals what? So it's our last computation problem to finish up the chapter. Use distributive property. Don't forget to annex that, put that 0 in there, because that 1 is not a 1, it's a 10. 1,562. And is that reasonable? Let's see. 142 times 10 would be 142. Move the decimal 1 place value. Yeah, that's pretty close. So we're good. And that's it. Good luck.